Today's video is on integration using residues. In today's video, I am going to use contour integration in order to prove that integral 0 to infinity dx by x power 6 plus 1 is equal to pi by 3. I request all of you to pull out your time and attention towards this video till the end as it is damn important and repeatedly asked question. Let's get started to solve integral 0 to infinity dx by x power 6 plus 1 using residue theorem. See, let me tell you, this is 0 to infinity. So I am changing from minus infinity to plus infinity. As you know that the distance from 0 to infinity is same as the distance from 0 to minus infinity. So here I need minus infinity to plus infinity. Since the integrand is an even function, so this is half times of minus infinity to plus infinity is nothing but 0 to infinity. Clear? So this is half times of minus infinity to plus infinity can be written as 0 to infinity dx by x square plus 1. Now consider integral c, the total integral c, that is dz by z power 6 plus 1 as c integral c. So c is nothing but the contour. So c is the contour consisting of a semicircle CR. So semicircle of radius r together with the real axis from minus r to plus r. And let me explain you the contour here. The contour is nothing but, see here, c is the given contour, closed contour. So which is a semicircle with center 0. So here is the center and radius r. So this is CR, the semicircle together with the real axis. So the real axis is from minus r to here, this one is plus r. So within this closed contour, we have to find the integral for integral c f of z dz, which is equal to 1 by z power 6 plus 1. So here, so what is f of z here? So f of z is nothing but integral c. F of z dz is nothing but integral c. This is dz by this value is z power 6 plus 1. Clearly, our f of z value is nothing but 1 by z power 6 plus 1. So now immediately we have to find the poles for using the residue theorem. So how we have to find the poles? So we have to equate the denominator to 0. So in order to find the poles, we have to equate the denominator to 0. Here the denominator is z power 6 plus 1 is equal to 0. Therefore z power 6 is equal to minus 1. See here, when we'll get minus 1? So as you know that cos pi value is minus 1 and sin pi value is 0. So I am writing, transforming this as z power 6 as minus 1 plus I times of 0. And see, z power 6 is equal to, this value is cos pi plus I times of, in place of 0 I am writing as sin pi. Clear? And now I am sending this 6 to other side. This will be z is equal to, this is cos pi plus I sin pi. If I send this 6 to other side, this will be 1 by 6. In general, I am writing z is equal to, this is cos of, this is 2n plus 1 into pi plus I times of sine. This is 2n plus 1 into pi per, this value is 1 by 6. This value is 1 by 6. So this can be written as z is equal to, this is cos of, this is 2n plus 1 into pi by 6 plus I times of sine, this is 2n plus 1 into this value is pi by 6. So n value runs from, so n value runs from 0, 1, 2, 3, 4 and 5. So we have to take 6 values as it is z power 6, 0, 1, 2, 3, 4, 5, 6. Clear? So if I keep n is equal to 0, so here if I keep n is equal to 0, what is our pole value? Z is equal to, if I keep 0 here, this will be pi by 6. So this value is clearly cos pi by 6 plus this is I sin pi by 6. Clear? And next, if I keep n is equal to 1 now. So if I keep n is equal to 1 now, this will be 2 plus 1, 3. So z value is equal to cos of, this is 3 pi by 6 plus I sin of, this value is 3 pi by 6. Next, if I keep n is equal to 2 here, 2 2s are 4 plus 1, 5. Z value is equal to cos of, this value is 5 pi by 6 plus I sin of 5 pi by 6. And next one, if I keep n is equal to 3. So in this, if I keep n is equal to 3, 3 2s are 6 plus 1, 7. So z value is equal to, this value is cos 7 pi by 6 plus I times of sine, this value is 7 pi by 6. If I keep n is equal to 4 here, So in this, if I keep 4 here, 4 2s are 8 plus 1, that is 9. Z is equal to, this is cos 9 pi by 6 plus I sine of. This value is 9 pi by 6. And next last thing here is, if I keep n is equal to 5, see what happens here. 5 2s are 10 plus 1, this is 11. This value will be cos 11 pi by 6 plus I sine of, this is again 11 pi by 6. So these are all the pole values. So if you keep n is equal to 0, 1, 2, 3, 4 and 5. So we have to check whether all these poles are within the contour, on the contour or outside the contour. And only for the interior poles only we have to find the residue value and we have to apply residue theorem. So let's get started to check whether these poles are within or on. First of all, we have to find the values for pi by 6, sine pi by 6 and all. So these are the 6 pole values. See here, just now we have found, and the first pole here is z is equal to cos of pi by 6 plus I sine pi by 6. So pi is nothing but 180 by 6, which is equal to 30 degrees. Cos 30 is root 3 by 2 and sine 30 is equal to half. If I substitute both the values, so this is our first pole value. And next one here, the second pole value is z is equal to cos 3 pi by 6 plus I sine 3 pi by 6. So pi by 6 is 30, 30 into 3 is 90. So cos 90 value is 0 and sine 90 value is 1. And therefore we got the second pole value as z is equal to minus I. And next one here, the third pole value is 5 pi by 6. So cos 5 pi by 6 plus I sine 5 pi by 6. Pi by 6 is nothing but 30. 30 into 5, it is 150. So 150 can be written as 180 minus 30. Clearly, if you see, so 180 minus theta is here. So here, sine and cosecant are positive, rest are all negative. Sine value here is positive. So here sine 180 minus theta. In place of theta we have 30. This value is minus sine 30 and rest are negative. So this value is negative. So cos 30 I have shown you, that is root 3 by 2 and sine 30 is half. And after substituting, this is our third pole value. And next one, coming to the fourth pole value, that is 7. This value is 7 pi by 6. So pi by 6 is nothing but 30 degrees. 30 into 7 is 210 degrees. So 210 can be written as 180 plus 30. Clear? 180 plus 30. So here we go. 180 plus theta. So here is 180 plus theta. Tan and cot are positive, rest are all negative. Whereas here cos and sine are there. So we have to write the negative signs here. This is minus cos. In place of theta we have 30 and here in place of theta we have 30. So cos 30 is root 3 by 2 and sine 30 is half, and this is our fourth pole value. Clear? And next one here is fifth one, that is 9 pi by 6. So cos 9 pi by 6 plus I sine 9 pi by 6. Pi by 6 is nothing but 30. 30 into 9, this is 270. 270 can be written as 180 plus 90. So here is 180 plus theta, and again cot and tan are positive and remaining are all negative. So cos and sine are negative, and see cos 90 value is 0 and sine 90 value is 1, and we got here as the fifth pole value. And next one here is 11 pi by 6. So here z is equal to cos 11 pi by 6 plus I sine 11 pi by 6. Pi by 6 is nothing but 30. 30 into 11 is 330 degrees plus I sine 330 degrees. So 330 can be written as 360 minus 30. Here also 360 minus 30. So 360 minus theta is nothing but cos 30 minus I sine 30. Cos 30 is root 3 by 2. And this is also half. This is our sixth pole value. So here we got all the pole values ready here, and let me show you. These are the pole values. First, for the first one is pi by 6 can be written as e power I pi by 6 is nothing but cos pi by 6 plus I sine pi by 6. This is 3 pi by 6. So this is cos 3 pi by 6 plus I sine 3 pi by 6. For all these 6 pole values, so these are the values and these are the coordinates. This is root 3 by 2 comma half. This is real part is 0 here. 0 comma 1, and this is minus root 3 by 2 comma half. This is minus root 3 by 2 minus half. This is real part here is 0, 0 minus 1, and root 3 by 2 minus half. So these are all the poles, and we have to check whether these poles are within or on or outside the given contour. And let's get started to solve this. See here, the first point is root 3 by 2 half. So this is root 3 by 2 and this is half. I am plotting here. So this is for the first pole. Root 3 by 2 half is for e power I pi by 6. So this is for e power I pi by 6. Clear? And next one is 0, 1. So this is 0 and this is 1. So for which pole it is 0 and 1? E power I 3 pi by 6. So this is for e power I, this is 3 pi by 6. And next one is minus root 3 by 2 half. This is minus root 3 by 2 and this is half. I am plotting here. And this is for minus root 3 by 2 and half is for I 5 pi by 6. E power I 5 pi by 6. And the next one is minus root 3 by 2 minus half. This is minus root 3 by 2 minus half is here. And this is for I 7 pi by 6. So this is for e power I 7 pi by 6. And the next one is 0 minus 1. So this is 0 and this is minus 1. And for 0 minus 1 here is e power, this is I 9 pi by 6. And next one is root 3 by 2 minus half. This is root 3 by 2 and minus half. And here is this one. This is for root 3 by 2 and minus half is for 11 pi by 6. So e power minus, sorry, there is no minus at all. I times of 11 pi by 6. So this is 11 pi by 6. So I have plotted all the pole values and see within this pole. So within this pole, so they are three interior poles. The first one is this one, second one is this one, and third one is this one. So these are all outside the given contour, outside the closed contour, and therefore there is no need to find out the residue values for this. Only for the interior values I am going to find out the residue values and substitute in residue theorem. So let's get started to find the residue value for the interior pole. So for the interior pole, what is the first interior pole? Z is equal to e power I pi by 3. So the residue value of f of z at the interior pole z is equal to e power I pi by 3 is equal to, this is limit z tends to e power, this is e pi by 3. So this is z minus e power I pi by 3 into this value is f of z. See here, this can be written as limit z tends to e power, this is I pi by 3, z minus e power, this is I pi by 3 into z value is 1 by, this value is z power 6 plus 1. If I substitute the limit in the numerator and denominator, this will be 0 by 0. So if it's 0 by 0, I am going to apply L'Hospital's rule. So according to our L'Hospital's rule, we have to make a derivative in the numerator as well as the denominator. See here, in the numerator, the derivative is 1. In the denominator, it is 6 into z power 5. Now, if I substitute this one, this will be 1 by 6 times of e power. This is I pi by 3 power 5. This will be 6 times of, if I multiply with 5, this will be 5 pi by, is it 3 here or 6? 6. So this value is a 6. So there is no 3 here. So this is I pi by 6. So this value is a 6. So if I send it to the numerator here, so if I send it to the numerator, this will be e power minus I 5 pi by 6. So this is the residue value of f of z at the interior pole z is equal to e power I pi by 6. So here, please remember, so this is our residue value at the pole value here z is equal to e power I pi by 6. And the next pole value here is, let me show you, the next pole value here is e power I 3 pi by 6. For e power I 3 pi by 6, the residue value I am finding. So for finding the residue value, see, the residue of f of z at the interior pole z is equal to e power I, this is 3 pi by 6 is equal to, this is limit z tends to e power, this is e 3 pi by 6, z minus e power I 3 pi by 6 into f of z. So f of z is nothing but z power 6 plus 1. So I have to substitute the limit in this. So this will be 0 by 0, and again I am applying L'Hospital's rule. So according to our L'Hospital's rule, what we have to do? So we have to make a derivative in the numerator as well as the Denominator. So for the numerator, the derivative is 1. For the denominator, this is 6 into z power 5. This is 1 by 6 times of e power. This is I pi by 6 power. This value is 5. This is 1 by 6 times of 3 5s of 15. So if I send it to the numerator, this will be I times of, this is 15 pi by 6. So here, what is this? This is the residue value of f of z. For the interior pole, z is equal to e power. This is I pi by 6. See here, this is our residue value. For the interior pole, e power, this is I pi by 6. And the next interior pole here is, I'm showing you the next interior pole here will be, that is e power I 5 pi by 6. That is e power, this is I pi by 6. Now the residue value of f of z at z is equal to e power, this is I 5 pi by 6 is equal to, this is limit z tends to e power, this is I 5 pi by 6. This is z minus e power I 5 pi by 6 by into f of z. So f of z here is z power 6 plus 1. If we apply the limit, this will be 0 by 0. Now I am going to apply L'Hospital's rule. So according to our L'Hospital's rule, we have to make a derivative in the numerator as well as the denominator and again substitute the same limit. So in the numerator, the derivative is 1 and in the denominator, this is a 6 into z power 5. And now if I substitute, this will be 1 by 6 times of e power. This is I 5 pi by 6 in power 5. So this is 1 by 6 times of e power I. 5 5 is 25 into pi by 6. So if I shift it to the numerator, this will be minus I times of, this is 25 pi by 6. So this is the residue value of f of z at point z equal to I 5 pi by 6. Now we got the third residue value. See, let me show you all the residue values here. The first residue value here is the residue value of f of z for the interior pole z is equal to e power, this is I pi by 6. And the next residue value of f of z for the interior pole, this is I 3 pi by 6. And the next residue value of f of z for the interior pole e power I 5 pi by 6. So these values are, I'm showing you. The first value here is for 5 pi by 6, the value here is 1 by 6 times of, this is 1 by 6 times of e power, that is I times of, this is 25 pi by 6. And next one here for 3 pi by 6, the value here is, for 3 pi by 6, the value is 1 by 5 times of, this is 1 by 6 e power minus I times of, this is 15 pi by 6. And here for the interior pole I pi by 6, the value here is minus 1 by 6 times of, this is e power, this is minus I 5 pi by 6. This is I times of 5 pi by 6. So here also there is I. So these are all the residue values. So after getting the residue values, we have to apply the residue theorem. We have to apply in the residue theorem. So according to our residue theorem, so what does this residue theorem states? According to our residue theorem, integral C f of z into dz is nothing but, this is 2 pi I times of the sum of the residues at interior poles. And meanwhile, what is this integral? So according to our question, so the integral value I'm showing here is this one. So this is the semicircle with center 0 and this is radius r. So the curve is like this. So this is from minus r to plus r. So this is the real axis and this is y-axis and this value is 0. So within this there are 3 poles. So we have to add up all those in order to find the residue theorem. See here. So this is the interior pole. So Integral C can be written as, so this is integral C f of z dz can be written as, this is from minus r to plus r. See here, the journey here is from minus r to plus r. As it is real axis, I am taking x axis, and here from this one, this is a CR. So this is a semicircle with center 0 and radius r. So this is a CR. This is f of z into dz. So now, according to our question, integral C is nothing but these two parts. Now, integral minus r to r, this is f of x dx, plus integral CR, this is f of z into dz value is equal to, this is 2 pi I times of sum of the residues. So what are the residues here? So the residue values are 1 by 6 times of e power, this is 1 by 6 times of e power, this is I 5 pi by 6, and the next one is 1 by 6 times of e power, this is minus 15 by 6. So e power, this is minus I, this is 15 pi by 6, and next one is minus 25 pi by 6. So here this value is 1 by 6 times of e power minus I, this is 25 pi by 6. And see, I'm taking 6 common. So if I take 6 common, this will be 2 pi I by 6. So this is minus I times of, this is 5 pi by 6, plus this value is minus I times of, this is 15 pi by 6, plus e times of minus this value is 25 pi by 6. As you know that e power I theta can be written as cos theta minus I sin theta. So this can be written as cos, this is 5 pi by 6, minus I sin, this value is 5 pi by 6, plus this can be written as cos, this is 15 pi by 6, minus I sin, this value is 15 pi by 6. And here this can be written as cos, this is 25 pi by 6, minus I sin of, this value is 25 again pi by 6. Sorry, 25 pi by 6. And now I need the value of all these. So in order to find the values, you see here, this can be written as, this is 2 pi by 2 pi I, this is pi by 6 is 30. So this value is cos 35 is 150. So this is 150 minus I sin of 150, and this is cos, this value is 15 into 30. This value is 450. 450 minus I sin of, the value here is 450. And next one cos 25 into 30. So this value is a 750 minus I times of sin 750. Clear? And now I need all the values here. For all these values, I am shifting this as, this value is 2 pi I into cos 150 can be written as cos 180 minus theta minus 30 here, minus I times of sine, this is 180 minus 30. And see, the next 450 can be written as, 450 can be written as cos 360 plus 90 degrees minus I sine of, 450 can be written as again 360 plus 90, and for 750 I am writing as 750. How can I write? See here, this can be written as a 750 can be written as cos of 2 times of 360, which is equal to 720 plus 30. See, 750 we got, minus I times of sine 2 into 360 plus 30 degrees. 30 degrees. So now I have to calculate this one, and let me show you. So this we have to start with 90 minus theta, and we have to end up with 90 plus theta. And again we have to start with 180 minus theta, end up with 180 plus theta, and start with next one 270 minus, and next with 270 plus, and next 360 minus, and next 360 plus theta. Here all silver, here tea cups. So here all are positive. Here sine and cosecant, tan, cot, cosecant are positive. And see, coming to this, so we have to write all the values here. This is 2 pi times cos 180 minus theta. Where it is? Cos 180 minus theta is here. Sine and cosecant are positive. See here, sine is positive, cosecant. So here, this is negative value. This is minus cos 30 clear, minus cos 30 minus I times of, here this is positive, this is a sin 30 as it is. And next one, 360 plus theta, where it is 360, all are positive, so we can write straightly as cos 90 minus I sin 90, everything is positive. In place of theta I am substituting here. And next one is 360 plus theta, so here also everything is positive, and I'm writing as cos 30 minus I sin 30. Now I have every value ready here, that is 2 pi I times of cos 30 value is minus root 3 by 2, and this is minus I times of, so cos 30 is half and this value is 0, and this is minus I into 1, so cos 30 value is again root 3 by 2, and this is minus I times of half. And now we can easily cancel these two, and this will be 2 pi I times of, so this is I by 2, this is I, and so this is minus I by 2, this is minus I, and this is again minus I by 2. So this is 2 pi I by, so if I take 2 as LCM and if I send this minus I outside, this is minus I square, this will be 1 plus 2 plus 1, clear. So I square value, as you know that I square value is minus 1, minus of minus plus 1, this will be 2 pi, this is 4 by 2. So this will be 4 by 2. And again if I cancel this one, and see here, there is a mistake here. So this is 2 pi by 6. See here, I have to take 2 pi by 6 common here. So there is 2 pi by 6 here, 6, 6. And here also 6. See, after cancelling these two and these two, and this will be pi by 6. So here, what is the value here? So this will be minus r2 plus r, minus r2 plus r. This is f of x dx plus integral cr. This is f of z into dz value is pi by 6 as r tends to infinity. See here, I am giving a clarity as r tends to infinity. This is cr into f of z dz value will be 0, and I'll show you how. In my previous video I have taught you. See here, this value is 0 as r tends to infinity, so we have to take z is equal to r into e power I theta, so we have to take modulus, so z value will be r, and after that we have to make a derivative, so r into e power I theta. So for e power I theta is again e power I theta into I into d theta, so here I into e power I theta is nothing but cos theta plus I sin theta. If I multiply with I, so dz value is r into d theta. So clear? So make a note of it. So in this also we have to apply the same version, and here in the previous question this is z power 4 plus a power 4 something, here it is z power 6 plus 1. So here also z power 6 plus 1, so this will be z power 6 minus 1 here. So if I cancel, r remains in the denominator, as r tends to 0, 1 by infinity value is 0. So this is the clarity which you have to take, as this is lengthy I am writing straightly as this one. And here this will be as r tends to 0, this will be minus infinity to plus infinity, f of x dx value is equal to, this is pi by 6. So I need, so this is half times of, so this is half times of 0 to infinity, f of x dx value is equal to pi by 6. If I send 2 to the numerator, so this will be integral 0 to infinity, this is x power 6 plus 1 into dx. If I send 2 to the numerator, this will be 2 pi by 6, so which is 3. Therefore, integral 0 to infinity dx by x power 6 plus 1 is equal to pi by 3. So this is the final answer. Hope you all guys understand. If you really understand, please don't feel that this video is lengthy, as I've explained each and every step from the textbook. And if you really understand, please practice. Definitely this is the question which you are going to see in the question paper. Definitely you can score more, pass it on to your friends. If you really like, please go through the playlist one. So many videos are uploaded for your preparation, and your preparation will be damn easy, and pass it on to your friends. Thank you for staying till the end.